Good afternoon, guys. Are you sleeping or what? Good afternoon.
Good afternoon,
Good
sir.
afternoon.
Good afternoon.
Good
Good afternoon.
Good afternoon, sir.
Okay, so we shall solve some of the problems today. So when are your internals? Any dates given as of now? Okay.
Yes, sir.
Aditya, you asked me a doubt, right, regarding that PVT. Okay.
Yes, sir.
Your answer is right. Okay.
Yes,
Okay.
sir.
Good. Okay. So today, shall we start then?
Yes, sir.
Yes, sir.
Okay. So we have seen a lot many problems, around 4 to 5 problems in the previous class, which deals about work done in a various processes, like all the 5 processes, starting from isobaric till the polytropic. We have seen if a process is given, how to calculate the work done using the expressions which we have learned. We have seen in the last few classes. So from now on, or from for this particular class, we will be dealing with work done which are not process related. That means we will be not specifying which process is this, whether it is a monotropic or adiabatic. It has nothing to do with the process. It is just other types of, you have listed out other types of work, is it? The flow work, the stirring work, expansion work, all the other types of work. So based on those, some problems can also be asked in the examination. So we shall see some of the problems on that, okay, and end up this particular work on heat. Now, here it is given the first problem, which is seventh one. It says that the quasi-static process occurs such that P is equals to V square plus 8 by V, where P is the pressure in bar and V is the volume in meter cube. Find the work done when the volume changes from 1 meter cube to 3 meter cube. That means I can take this particular value to be V1, which was initial. It has changed it to what? It has changed it to the value of 3, which is V2. I'll be taking it as V2. Now, you know that the expression for the work done in the displacement work is given by W1 to 2 is equals to integration from 1 to 2 P into dV, right? Okay. P here is given as V square plus 8 by V. Substituting the same in the P here. So substituting P here, it is V square by 8V. Now, performing the integration. Integration of V square is V cube by 3. And integration of 1 by V is the ln V. Taking out constants outside. So 8 you have taken outside. So integration of V square is what? It is V cube by 3. And integration of 1 by V is nothing but ln V. Over the limits 1 to 2 here and over the limits 1 to 2 here. Substituting the limits, what happens? 1 by 3, you can just, as a constant, you can take it out. V cube over the limits 2 to 1. So it is V2 cube minus V1 cube. Okay. Similarly, 8 is a constant, you can take it outside. It is ln V over the limits 2 and 1. So it is ln V2 minus ln V1. You know the value of V2, that is 3. You know the value of V1, that is 1, which is given in the problem. Just substitute the same things here. Okay. And you can calculate your work done as 17.45 kilojoules. Any doubts in this problem?
No, sir.
Simple. Okay. Next. This I will be leaving as a blank. I will be sending the notes, the same notes which you are seeing now. The same notes will be sent to you today. So this particular thing is left blank with a purpose. Okay. I want you to solve and showcase this particular answer in the next class. Okay, so this particular slot, you have to fill it up in your notes. Okay, next. This type of problems is very interesting and important too. We will see that what kind of problems are this. A fluid is contained in a cylinder which has a stirring device rotating at 8,500 rpm. So there is a piston arrangement here like this. There is a piston and there is a stirrer. Okay, and the stirrer is rotating at an rpm of 8,500. So it is rotating like this. Because of rotation, the energy is sent into the system. That means you are working on the system. So if you are working on the system, should I take it positive or negative?
Negative.
Excellent. So here you are taking the work to be negative, which is because you are working on the system. Now, because you are working on the system, this particular yellowish fluid, what happens? It gains its energy, right? Because of the gained energy, what it will do, it will work on the piston so that the system gives you the work and it pulls out the piston away. It pulls out the piston away against the atmospheric pressure. Since the atmospheric pressure will be acting right on the piston, on the other hand, against that, your piston will be pushed away. Now, in this case, that means in this case where the piston is being pushed away, here the work is done by the system. Should I take it positive or negative?
Positive.
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 Very good. So here, when you're turning and agitating the mixture, you're working on the system, so it is negative. Here, the piston is being pushed out by the system, so the work is done by the system. So here it is positive. Remember this. With an average torque of 1.75 Newton meter, that is 8,500 rpm is the speed at which the agitator is revolving, and the torque at which it's revolving is 1.75 Newton meter. Okay, the piston is frictionless and held against the fluid due to atmospheric pressure. So against the atmospheric pressure is acting on the either side, he says, which is equal to 100 kPa. 100 kPa, you know the value of the atmospheric pressure. Okay. Now, the diameter of the piston is being given, the diameter of the piston here, that is being given as the 50 centimeters. If it moves outward by 65 centimeters, that means how much it is moving away? How much it is moving away?
65 centimeters.
It is moving 65 centimeters away. So in this case, you have to determine what is the net work transfer for the system. So here it is a negative work, here it is a positive work. So you need to add these two to get the total work. So that is the problem. Let us see how it goes. Now, look here. Let W1 be the work done on the system using the stirring device. So that's why it is what? That's why it is negative. Second thing, W2 be the work done by the system by moving the piston against the atmospheric pressure. So you are doing work by the system, so it is positive. So W1 is work done by the stirrer, it is negative. W2 is work done by the piston, which is positive. So the net work done by the system is given by W1 W1, what are you doing, man? You are just rotating with an agitator, right? So in order to calculate the work done by this, you have the formula 2 pi nt divided by 60. Correct? So this is the formula by which you can calculate your work done. Is the screen visible to you? Is the screen visible, man, by the way? Just for the confirmation.
Yes, sir.
Sir, your voice is breaking. Sir.
Yes?
No, sir.
It's not visible.
Visible,
Okay.
sir.
Visible.
Can you see 2 pi nt by 60, which I have written just now?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So W1 is nothing but what? W1 is nothing but your shaft work, which is given by 2 pi nt by 60. You know the value of speed, which is given here. You know the value of torque, which is given here. Substitute and calculate the value of W1. Simple. Just substitute the value of W and N, torque and speed. You'll get the value of W1 as minus 93.41 kilojoules. Okay, this is work done on the system. That's why it has to be taken negative. Keep this in mind. Okay, this is work done on the system. That's why it has to be taken negative. Next, W2. W2 is what, man? You are moving the piston against some pressure, right? You are moving the piston against some pressure that you have to calculate now. So displacement work is given by P into dV. Again, change in the volume is what? A change in the length into area, correct? Now I want the displaced volume. So this is the area, and if it has moved this much with the amount of what I can say dl, if it has moved with this much with the amount of dl, if I multiply these two, will I get to the total volume dv, changed volume dv? Will I? If I multiply area with the change in the length, will I get the change in volume? Yes or no?
Yes, sir.
Okay, so that's why your dV can be written as A into dl. So P is the atmospheric pressure against which the piston has to work, that is 100. And A is area of cross section, so 50 centimeter he has given, so pi d square by 4. You can use this to calculate the area of cross section. And dl is the change in the length, which is 65 centimeter, to which it is moving. Calculate, then you'll get the value of W2, which is 12.76, and it has to be taken positive. Why? Because it is work done by the system. Now, net work done is add these two here. So you'll get W1 plus W2 minus 93.41 plus 12.76. So the net work done by the system is minus 80.7 kilojoules. Any doubts in this problem?
No, sir.
Cleared? Understood, man?
Sir.
Okay. Only Aditya is responding. What about others? No? Okay. Just listen. Okay. Now, we shall move to the next problem now. The fluid in the horizontal cylinder, it is same as the previous thing. Some parameters would be given and some parameters you have to calculate. The same thing. The fluid in the horizontal cylinder is fitted up with a frictionless leak-proof piston in a continuously agitated by means of a stirrer passing through a cylinder cover. The cylinder diameter is how much here? It is 400 mm during the stirring process of 10 minutes. So he is stirring it up for 10 minutes. For 10 minutes continuously stirring it up. The piston moves away slowly outwards to a distance of 485 mm. So at a distance of dl is how much? 485. So 485 mm it has moved. The network done by the system. See, this word is very important. The network done. So here he has given the network done. So previously we have been asked to calculate the network done, but in this problem he has given the network done. He has used the word by here, so it is positive. Okay, during the process is 200 Newton meters. So Newton meter is nothing but joule again. Given the speed of the electric motor driving the stirrer is 840 rpm, so speed of this particular thing is given 840. Estimate the torque required to drive the shaft output of the motor. So here in this case, what you have to find? You have to find the value of torque at which this has to be rotated at a speed of 840 in order to get the net work done of plus 22,000 joules. Okay, the same thing, same procedure can be followed up. So W1 be the work done on the system using the steering device. So this is W1 here and this is W2. Okay. The summation value has been given here. So W1 is what? Network done on the system. It is negative. W2 is network done by the system through the piston. It is positive. So W net is equal to W1 plus W2. W net is given as 2000. W1 plus W2. Okay. Individually, we shall try to calculate. Now, W2 is again P into dV. Change in the length, dV can be replaced as area into change in the length. Change in the length, you know, area, you know, pressure, you know, just substitute, you will calculate the value of W2. Since you know the value of W2, since the W net is given, you can calculate what is W1. Yes or no? Just substitute here. So W2 you have got to know. W net is equals to W1 plus W2. Substitute, you'll get the value of W1. So once the W1 is known, the power of the shaft is what? W stirrer by time. So time is taken as 10 minutes here. Always for joules per second is watt. That's why you have to substitute in seconds always. So 10 into 60. So this particular thing is very important. I have just even highlighted that. So if you substitute whatever the value of joule would be there per second, it will be watt. So power of the shafts is nothing but 6.95 watt. So the power of the shaft you have even calculated in the last question, which is known as 2 pi nt by 60, right? The power of the shaft is 6.95 kilowatt. So speed of the shaft, you know already, which is driven by 840 RPM, which is here. Okay. And everything else you know, except from the torque here. Yes. So everything, all you know is you can calculate your torque straight away as 79 into 10 to the power of minus 3 Newton meters. Any doubts here?
No, sir.
Understood?
Yes, sir.
What about others, man?
Yes, sir. Yes, sir. Got it.
Balloon problems. Next you will come across the balloon problems. These are very interesting. All the problems will go at a single stretch. Same procedure need to be followed. So kindly concentrate. Okay. A spherical balloon of 1 meter diameter. So there is a balloon of 1 meter diameter, contains a gas at 240 kPa and 290 Kelvin pressure and temperature respectively. When the gas inside the balloon finally heated, so gas inside the balloon is heated, its pressure rises to 4.85 or 485 kPa. So initially it was how much? 240 kPa. From 240 kPa, it has increased to how much? 485 kPa. So this becomes the initial one, and this becomes the final. And the pressure is being proportional to the diameter. So this is very, very, very important. You have to look for this particular sentence in this type of problems. Okay. Sometimes he might give pressure is directly proportional to the square of diameter. Sometimes he might give pressure is directly proportional to the cube of diameter. So you have to look for this particular sentence in the balloon problems. So accordingly, you have to solve it. Okay. So here it is just pressure is being proportional to the diameter. Determine the work done by the gas inside the balloon. So balloon problem, we shall see how to do it. So initially D1 is 1 meter, P1 is 240, T1 is 290, P2 is 485. This final pressure is being given. In this particular question, he has given pressure is proportional to diameter. So that is pressure is proportional to diameter here, correct? So if I take out the proportionality symbol, what should I do? I should incorporate a constant. So that constant is here. Okay, that is C. Similarly, so if P is equals to C into D, I can write for the initial state as P1 is equals to C into D1 and P2 is equals to C into D2, correct? So in this particular, extracting C from this, so sending D1 to the other side. So C is equals to what? P1 divided by D1. C is equals to P1 divided by D1. So since you know the value of P1, since you know the value of D1, you can know the value of C. Just substitute the value of P1 and substitute the value of D1, so you'll get the value of C. Next, for the other case, the final state, that is P2 is equals to C times of D2. Here, you have calculated the value of C. You know the value of final pressure, so you can calculate what is the D2, which is second state 2 diameter. That is D2 is equals to P2 divided by C. P2 here has been given in the problem as 485. C you have just calculated here. Substitute, you will get the value as 2.02 meters. So now you have calculated the value of D2, that is 2.02. How to proceed further? Again, go with the displacement equation here. Okay, so W1 to 2 is equals to integration from 1 to 2 P dV. This is the displacement work definition, correct? Now, let P be as it is for of now. And can you write P dV as area into change in length, right? Area into change in diameter. Now, what is the area? It is pi d square by 2. Okay. Now, for this, in order to understand, you can come here. Okay. Volume is what? Volume of a sphere. Anyone knows about the volume of the sphere? What is the volume of the sphere? Yes. Anyone?
Dubai for Panasphere.
Muhammad Khalil. Yes, man. What is the volume of the sphere?
4 by 3 pi r cube.
R square.
4 by 3
4
pi
by
r
3 pi
cube.
r.
Okay, 4 by 3 pi r cube. In terms of diameter, I can write it as d by 2, so that in terms of diameter, it is pi d cube by 6. Okay, in terms of diameter, V is equals to pi d cube by 6. Now, V is equals to pi d cube by 6 here. I'll be differentiating on the both sides. Okay, so therefore dV is equals to pi by 6 as it is. Man, what is the differentiation of d cube?
3D square.
So it is 3d square. So here it was 6, here it is 3. So 1's a, 2's a. So finally, the dV is equals to what? Pi d square by 2 into dd. Okay. This particular dV, I will take in here. So what I have done, I have changed the value of dV to pi d square by 2 into dV. Okay. Any doubts up till now? Because this is the crucial
No,
part
sir.
of the problem. If you understand this, everything is easy. Only what you have to substitute to P, what you have to substitute to dV is only the problem on spheres. So if you balloons, so if you clear the this, rest all is simple. So dV, have you got? You've gone through the sphere volume. In that sphere volume, you have extracted in terms of diameter, differentiated both sides so that you'll get an expression of dV in terms of dV. Okay, that you have substituted here. Now, P, you have assumed it to be C into D, right? So the same thing I'll be substituting here. So P is substituted as well as C into D. Okay. Now, taking out the constants. So what are the constants here in this particular expression?
C and pi by 2.
So C and pi by 2 are the constants I'll be taking out. So D into D square is D cube. So what is the integration of D cube?
D to the power 4 by
Two
4.
D
for
to the
4 by
power of
4.
4 divided by 4. So here 2 into 4 is 8, which I am written here. Okay. D to the power of 4 over the limits 2 and 1. So D2 to the power of 4 minus D1 to the power of 4. Clear? So your work done from 1 to 2 is finally given as what? C pi divided by 8 into D2 to the power of 4 minus D1 to the power of 4. Okay. So you know the value of D2, 2.02, I guess. Oh, yes, so 2.02 you have just calculated. D1 is 1. You know the value of C. Substitute all the values. You'll get the final answer as 1.41 megajoules. Any doubts in this problem?
No, sir.
So the heart of the problem lies in this particular step. Okay, if you got this right, everything is correct. Same thing in the next problem. So in this problem, everything is same, but he has changed this word. Where it is? I just use a highlighter for this. The gas pressure, just a minute. The gas pressure is proportional to the cube of the diameter of the balloon. So what he says here, the gas pressure is proportional to the cube of the diameter. That means you can come here. So in the previous case, you have taken P is proportional to D. So here you have to take P is proportional to D cube. Rest all the things, everything remains same. Okay. Same thing, you can just integrate it, substitute P as C into D cube, which is here. dV as what? dV, first you have to calculate V in terms of D, that is pi D cube by 6. You have to integrate, differentiate it so that you get the expression for dV. Just substitute here, which is same as in case of the previous problem. Okay, here you'll get d to the power of 5 because c pi by 2 are constants that will take it away. But p is c d cube. So d cube into d square. So how much? D cube into d square.
D to the power 6.
So d to the power of 5. So d to the, not 3 into 6 Aditya. A to the power of m into a to the power of n is a to the power of m plus n. Okay, so it is d cube into d square is d to the power of 5. Integrate it again, same expression, you can do it. Okay, so that is that problem. Of course, this is a second problem which I prefer you to try and submit in the next class. So two problems for this class, that one and this one. The spherical balloon has an initial diameter of 25 centimeters. So D1 he has given contains the air at 1.2 bar. P1 is given. Because of the heating, diameter of the balloon increases to 30 centimeter. Even the value of D2 he has given directly, no need to calculate. Okay, the process, the heating process, the pressure is found to be proportional to its diameter. Same thing, same as the previous first problem. So pressure is being proportional to diameter. Okay, proportional to, so P is equals to C into D here. Calculate the work done during the process. So need everyone to calculate this particular and be ready for the next class. Okay, so those were few problems on other types of work other than the process related. Any doubts in the problem solved today? So we have solved the problems on stirring. We have solved the problems on the balloon. Okay, still there are many kinds of problems. One like there are the problems on expansion process. There are problems on engines. Just because of the time constraint, we could not do it. So once every module gets completed, we shall have those problems also if the time permits. Out of all, these problems are important. Okay. Any doubts? Data exhausted. Okay. Any doubts in this today class
No, sir.
in two types of problems we
No,
have
sir.
discussed? Okay. So soon after the class, I'll be sending you the notes. This particular notes which we have used to analyze all the concepts. Okay. You can study from that and you can write the notes from that. And there will be a mock test by now. You have received a notification, I guess, correct? There will be a mock test on Saturday, first half. So that will be considered as assignment number 3 for you. So that mock test should be considered as assignment number 3. The questions will be given on spot. So the questions will not be given previously. And the portion for that is the real gases and the work and heat. And the portion for your internals is real gases without problems, and you have to not solve the problems on that. Real gases, work and heat, and first law of thermodynamics. So most probably it might be around the next week by this time. So within that, we have to complete the first law. First law is easy when compared to work. So any doubts in this particular two types of problems we have solved, balloons and the steering work problems?
No, sir.
Okay, so we shall take that and then Abdul Rahim.
Sir, when
Internals, most probably it might
Present.
start
Present,
from
sir.
27th, expected date.
Sir, college will start, sir, offline.
Offline college has started already, 23rd. They have asked your final years to come, the college.
That's only for
And
5 years, right?
Sir,
Sir, not
when will it be for us, sir?
That's only for
that
5
too
years,
only
right?
for final years, man. Only for final years. Okay.
Sir,
Sir, when will it be for us, sir?
Huh?
Excuse me, sir.
Amal? Ah, yes, Lucky.
Sir, when will be for us
Sir, that
class?
Amal, tell me.
Sir, when will be for us online class? Offline class?
Offline class. For you, as per the government regulation, only for the final years they have allowed us allowed to go to college to take the offline classes. For the third years and the second years, no directions has been issued till now. enough. Most probably next semester.
Okay.
Who knows?
WhatsApp
Excuse me,
message is
Lucky.
someone tell.
Okay, sir.
sir.
Lucky. Yes, ma'am.
Sir, the notes for the internals is not yet posted, sir. Please can you post today, sir?
Yes, man. Yes, man. So work and heat has been completed just now. No,
Okay.
I have sent you right. So I'm
Okay.
just posting it in the Google Classroom immediately after the class. You can refer.
Okay, today I'll be posting, no, sir?
Yes, yes. Today itself
Okay,
after
thank you.
within 2:30, I'll be posting it.
Because the notes is not enough, so nothing I will return properly, sir. Everything is off.
Yes, yes, yes.
Okay, thank you, sir.
Okay, okay. I'll be sending it. I'll be sending it. Okay, and you have to update your notes, everyone.
Yeah.
Okay, you have to update your notes because
Not copy,
barely
updated, sir.
looking into the notes which is given by me is of no use. I am saying it. If you write the
Okay.
notes, then only you will learn. Okay,
Okay.
update your notes. And I have said you right. 5 assignments, 5 note submissions will be there, and that will be considered very, very seriously.
Okay,
Okay.
sir. Yeah.
So immediately after the completion of, since your model number 5 is not completed because the problems is being left over and not asking you to submit. Otherwise, by now you need to submit your model 5 and model 2, everything. Keep it ready, man. Again, it will be a burden for you at the last. Keep this in mind.
Okay.
I am
Today
alerting you
will
every
start,
day.
sir.
Yes, Lucky?
Both the subjects are there, sir. Even Max is also
Some
there.
exam would be
Not getting, man. Not clear.
So what
Lucky.
about internals, sir? Internals.
Internals are there. It will start around 27th, I guess. Not any official information, but
Okay.
expectation.
So offline or online?
Online, online, online. Okay.
So
Abdul
some exam
Rahim.
would be offline or online.
SEM exam. Coming to the SEM exam, man, definitely do not expect it to be the previous semester, how it has been waived off, and looking at your previous semester percentages, how the current semester external examination marks were allotted, that will not be done for this semester. This is very, very clear instructions given by university and MHRD, which is Human Resource Development Ministry. That is the clear instruction given that the exams would be there, which will be offline. Okay, it should be offline, and you have to come and write. So for that sake, even I am not just skipping any of the topic for you. I'm explaining each and everything. Okay, just go through my classes, go through the notes given, complete your notes. Don't neglect the subject. Okay, Abdul Rahim, Akash.
Present, sir.
Next is Bharatesh. Abdul Rahim is there. Devdarsh,
present, sir.
Arshit,
Sir, my battery is draining, sir. Shall I leave?
Mohammed Khalil. Where are you? Okay, I marked you. Fine. Arshit, Devdarsh, I have marked you. Pratik Kesi. Pratik Kesi, I have marked you. Wait, man. Come in order. Arshit, not bad. Bharatesh, I have marked you. Hashir is there. Fine. Hazim.
Present, sir.
Next is Srijin,
Present, sir.
then Kumar, Kiran Kumar, Kishan Kotian,
Present, sir. Present.
Lucky Somanna is there. Malatesh, okay. Kishan Kotian is there. Okay, fine. Well,
Sir,
Roy
can we leave,
Melvin.
sir?
Hazim, you can. Those who have given your attendance, you can leave, man. We should meet up in the next class. Melvin Pinto, Muhammad Khalid, how marked you, Lucky? Muhammad Munawar, Mohan Chandra, Muhammad Khalid
Present,
is
sir.
there. Mohan Chandra is there. Okay. This is Muhammad Suray.
Sir, Marvin.
Present, sir.
Okay. Munawar, Muhammad Suray.
Sir, Marvin.
Yes, I have marked you.
Present. Mohammed
Nishant
present,
Raj,
sir.
Suray is there. Nitesh. Okay. Numan.
Present, sir.
Numan. Next is
Present, sir.
Pradeep. Pradeep Shetty. Praveen Suryakant. Pradeep Shetty is there. Okay.
Nishan present.
Nishant, I have marked him. Nishant, I have marked him. Praveen Suryakant. Raid. Raj Prasad. Okay. Rajat Madiwal. Rakesh GM.
Present, sir.
Okay. Next, Ramachandra.
Present, sir.
Dick Lobo. Priyadangar.
Present, sir.
Present, sir.
Siddesh PN. Siddesh PN.
present.
Saurabh Shetty.
Present,
Okay.
sir. Sohan, you didn't call my name, sir.
Sohan. Sohan, I have marked it. Sohan. Siddesh
Okay,
PN
sir.
is not
Siddesh,
there.
sir.
Okay.
Sir, present, sir. Siddesh.
Okay. Siddesh. Srinivasan. Stephen. Stephen.
Present, sir. Present, sir.
There. Vaibhav. Vaibhav is there. Hey, why are you absent, mother, for the last few classes? Varun.
C.
Vignesh.
So, sir.
Okay. Varun. Vignesh is there. Marvin is there. Wayne is there. Swaroop. Chirant. Raj Prasad. Raj Prasad. I have marked you, Raj Prasad. Marvin, yes. Swaroop, yes. Darshan is Shetty. Darshan, yes. Karthik, yes. Chirant. Chirant. Chirant.
Sir, I couldn't answer. Sir. Present.
Lucky I have marked you.
I couldn't answer, sir. Lost a network.
Okay.
Sir, Abdul
Anish.
Sami.
Abdul Sami. Wait, man, I have not called your name. Wait. Anish Pinto. Anish Pinto, yes. Next, Prakyat. Abdul Sami. Praveen Nair.
Sir, present.
Yes, sir, present.
Okay. Ditya Shetty is there. Amal PK is there. Amok P. Hekade is there. Chandan Rao P. Chandan Rao. Chirayu. Cyril Vikas. Darshan Shetty. Midlaj.
Sir, Prasad, present.
Hello, Jitay Prakyat. Narendra Naik. Mohammed Midlaj is there. Okay, fine. Narendra Naik. Omar Zaidan. Rachana Shetty. Hitesh Kumar. ठीक से हम आपके Krishnaraj. Okay, guys, have a nice day ahead. I'm going to have my